Good evening. On behalf of the Indiana University College of Arts and Sciences, I'd like to thank you for joining us tonight. I'm Vanessa Clow, and I serve as the college's Director of Alumni Engagement. Our Food for Thought live streaming series serves as an opportunity for our alumni and friends to hear from faculty experts, explore topics of interest, and stay connected with IU and the College of Arts and Sciences, regardless of your location. On April 8th, 2024, North America will experience a total solar eclipse, which will pass over numerous states and countless locations, including the Indiana University campuses in Bloomington, Indianapolis, Kokomo, Richmond, and Columbus, Indiana. In collaboration with the IU Alumni Association, we are delighted to bring you a special series about this astronomical phenomenon. Tonight's presentation will offer insights into the challenges and rewards of photographing a total solar eclipse. At this time, I'm delighted to introduce this evening's featured presenter, astronomer and photographer, Zolt Levay. During his tenure at the Space Telescope Science Institute as the principal science visuals developer, Mr. Levay played a pivotal role in translating data from NASA's Hubble Space Telescope into captivating images and visuals for the dissemination of scientific findings from Hubble and other observatories. In his retirement, Mr. Levay continues to pursue many interests, including deep sky astrophotography and other personal photography projects. Finally, I'm delighted to share that Mr. Levay is a college alumnus, earning his BS in astrophysics before pursuing a master's in astronomy from Case Western Reserve University. Following his talk, Mr. Levay will be joined by Professor Paul Macklin for the audience Q&A session. Dr. Macklin is an associate professor in the Department of Intelligent Systems Engineering and associate dean for undergraduate education at the IU Luddy School of Informatics, Computing, and Engineering. His lab develops open source computational tools for multicellular systems biology. He is also leading the Luddy School's Eclipse outreach, which includes an app that will be used to study animal behavior during the April 8th total solar eclipse, and a live eclipse web stream on YouTube. You can submit your questions at any point during this evening's discussion. Simply click on your Q&A tab located in your webinar toolbar. Hover your mouse over your screen and your toolbar should appear. Closed captioning is also available. Now, it is my pleasure to welcome Mr. Levay for his presentation. Thank you.
Thank you, Vanessa, and thanks everyone for joining tonight. I'll share my screen. So as you all know, and as Vanessa mentioned, we're going to be treated to a unique and spectacular event on April 8th. Unless you've been living under a rock somewhere, I'm sure you've heard a lot about this. And we're fortunate right here in Bloomington that we're very near the center of the path of totality, which means that we'll get a fairly long totality during the eclipse. So we're very fortunate here. So what I want to talk about is photography. You know, eclipses are a kind of a special case. There are many challenges, but if you can overcome those challenges or meet those challenges, you get some really interesting and different pictures. So just a little bit of background about some things about the eclipse that I'll reiterate. I'm sure you've seen a lot about the eclipse already. And I'll talk about, in general, what types of subjects you might consider photographing, because there's a whole range. And, you know, even if you just have a cell phone as a camera, cell phone cameras today are very, very capable, and you can get some very, very nice pictures, but you might want to keep some things in mind while you're trying to photograph during the eclipse. But I'll also talk about some more advanced techniques. If you've got a capable digital camera and some nice lenses and maybe some other equipment, you can get some close-ups similar to what is here on this slide. These are from the last total eclipse across the country back in 2017. And just I'll touch on some additional aspects to more advanced photography and how to process the images for maximum effect. So just a little bit of background. Here are two photographs of two different solar eclipses. These are the two solar eclipses that I was fortunate enough to see. The first one way back in 1970, when I was still a student in high school. I was a senior in high school, getting ready to come here to IU and get my degree in astronomy. So seeing a total solar eclipse under those circumstances was an amazing event. And I was very fortunate that I didn't live very far from the path at that time. And of course, we didn't have digital cameras back then, so I was able to take some photographs through my own telescope on film, of course, back then. And this is one of the results. So that was a great experience. And then the other one, of course, is from the 2017 eclipse. And I was fortunate to be able to go to Wyoming, Grand Teton National Park, and where the conditions were ideal, and got some pretty amazing results. So a little bit more background. Again, I'm sure you've seen all the details of where to be during the eclipse and when to be there. That's the primary consideration for a total solar eclipse, is being at the right place at the right time, because the path of totality is fairly narrow. It's about 100 miles wide. And again, we're fortunate here in Bloomington to be very near the center of that path, so we'll have the maximum duration. But if you are outside that path, you will not see a total eclipse. You will see a partial eclipse. You will not see the corona. You will see the sun being bitten into by the moon, and that's all you will see. But if you are within the path, then you'll see a spectacular event. This is a tool put together by this gentleman from France, Javier Jubier, and it's actually a Google map, and you can click on any point on the map, and up comes this whole wealth of information for where you are, where on that map. So it tells you when the eclipse will start, when the maximum duration of the eclipse, maximum extent of the eclipse is, and when it will end, and a few other interesting details. Now, I will point out that in the app, in the map, the information that comes up, the times are in what's called universal time, which is Greenwich Mean Time, the time in England, so which is the standard time for astronomers. So it's worldwide. Everybody's on the same time. It's not like time zones. So, but you can translate that easily to local time here. At daylight, we're in daylight time now. We're 4 hours earlier than universal time. So the eclipse will start at 1:49 Eastern Daylight Time. Maximum will be the center of totality. The time of totality will be at 3:07 p.m. And the eclipse will end completely at 4:22. So that's the time. But again, with this tool, you can see this for any place. And if you do use a tool and you just click on nearby locations, you'll notice that the timing doesn't change all that much. But if you go farther away, if you go, say, down to Kentucky or something, or Illinois, where it's going through, you'll see different times. The eclipse comes from the southwest, and goes up to the northeast, all the way from Texas into Maine. So if you click along that path, you'll see different timings. So what can you expect to see? So this is a photograph taken during the 2017 eclipse, again, out in Wyoming. And it's a wide view with a wide angle lens on a regular camera, on a DSLR. And it shows what the sky basically looks like. And you can see that it kind of looks like sunset. Instead of normally when the sun sets, after the sun's gone below the horizon, you see this glow mostly on the western horizon, but during an eclipse, you see this glow all around the horizon. And you see the sun up in the sky. It's kind of small because this is a wide angle lens. And we'll talk about all that stuff a little bit more later. So what kinds of things can you expect to see in photographs? So, the landscape around you. So again, even during the partial phases, the light changes dramatically. So as it gets closer and closer to totality, more and more of the sun is covered up. You'll notice that the quality of the sunlight is very different, and especially during totality. You kind of want to capture that. It's very difficult to capture that effectively in a photograph, I think, but it's certainly worth trying. And so again, the light, this is during totality, looking across the mountains, and you can see again that everywhere you look, it kind of looks like sunset, even though it's in the middle of the day. So it's kind of weird. And then shadows are very interesting. So as the shape of the sunlight changes because the moon is going in front of the sun, if you happen to catch the annular eclipse that happened last October, you may have noticed these effects where this photograph shows sunlight coming through leaves of a tree and casting shadows on the ground. And those shadows are little images of the sun. Normally, you don't notice the shape of the sun because they're just overlapping kind of fuzzy circles. But when the sun is partially eclipsed, you notice these very odd shapes to the shadows. And so that's a fun thing to capture. And it doesn't have to be leaves through a tree. Any small holes will create these, will act as pinholes and will create these images of the sun. So even if you hold your hands up and cross your fingers against each other, and those little spaces between your fingers you hold up, and you'll notice the shadows similar to this on the ground or against a wall or something. Or take a colander, and the sun shining through the holes in the colander will create the same kinds of effects. So those are fun things to try to capture. Also, since the sky gets darker, you may notice that stars come out and brighter planets will appear in the sky. And in this case, the way the solar system is arranged right now, you're likely to see several of the brighter planets, Jupiter and Venus and Mars, not too far away from the sun. Mercury is up there too. It's a lot fainter. You may see Mercury, but that's always fun to look for, and the brighter stars. So if you're more ambitious and you've got some more sophisticated equipment, you can take close-ups. So the partial phases where you might see some spots on the sun, the sun is actually becoming more active. It goes through an 11-year cycle of activity. The more active the sun is, the more sunspots there are. These are dark patches on the sun. They're kind of like little storms on the sun. And there's actually a sunspot in this picture. It's hard to see at the scale, but that's something to look for in close-ups. And then totality, of course, is the main event. And if you're able to take close-ups, there's all kinds of effects that happen. So things called the diamond ring, Bailey's beads. I'll explain those a little bit later. The corona, of course, is the thing that most people are excited to see, because that's something you just cannot see unless the sun is blocked by the moon. So and it's a very dramatic effect. And there's other effects too. And then finally, the kinds of things you can do. This is a timing event. I mean, right? It happens over a couple of hours. Totality lasts a few minutes. So it's always fun to try to capture that time element. So whether you take just a series of still photographs and put them together in a time-lapse video, or take video. Lots of people take video during the totality, and you can see the whole thing unfold. Those are the kinds of subjects that you might consider thinking about. Now, again, the challenges in this, so those are the opportunities. The challenges, I mentioned location and timing. Got to be in the right place at the right time. I think we all understand that, Bloomington is a special place. If we stay put, we'll be in the right place at the right time, assuming the weather holds out. And of course, the sun is a particular place in the sky. You kind of got to be aware of that. This is happening in the afternoon, so the sun is going to be fairly high in the sky, about over 50 degrees up. That's consideration. Now, some people like to take pictures of the eclipse against an interesting background, like this great image, which I didn't take, unfortunately. I wish I had. But there's a really talented photographer who found this location also in Wyoming, I believe, and got a nice juxtaposition of the eclipse against this nice background. But again, you notice that the sun is very high in the sky. So there's a lot of sky there. And it's a challenge to get a foreground. Sun is well placed in the sky against a foreground, but it's always possible. And you got to think about how long this is. I mentioned the totality is about 4 minutes. The total eclipse is about 2.5 hours. So, you got to consider that. And then the sun moves through the sky, as everything moves through the sky. The stars rotate around the sky because the Earth is rotating. It's not the sky. And so you got to consider that. Now, like in this case, in the case of this image, the camera was stationary, and this photographer took pictures every, I don't know what it is, maybe 15 or 20 minutes, and the sun moved that far, and he took another picture, and he just took a sequence of images. And I'm sure there were separate frames that he composited later in post-processing, but that's one of the kind of things you can do. But you do have to be aware that the sun is moving through the sky, so take that in effect. If you've taken close-ups and your camera's on a tripod, you gotta be moving the tripod if you want the sun centered in your field of view. And then you also have to be aware that the sun, how big the sun is in the sky, which isn't very. The sun subtends about 1/2 degree, which for many people that doesn't really mean anything, but we sometimes think that the sun and the moon are further larger in the sky because we'll see them, close to the horizon, and they will look like they're very large, but in fact, they're fairly small in the sky. And one way to estimate that is to hold your thumb out at arm's length, and it turns out that your thumb is about 2 degrees wide. So that's 4 times the diameter of the sun and the moon. And the sun and the moon are very close to the same size. That's why we can have total eclipses, because they happen to be, it's just happenstance, but they happen to be almost exactly the same size. So it's possible for the moon to completely cover the bright part of the sun. So, if you're taking photographs, you got to be aware that if you're taking a very wide angle view, the sun's going to be fairly small in the sky. If you want to take close-ups, you have to use a longer focal length lens to get enough magnification to fill your frame. And then be aware that there's a huge range in brightness, not only between, first of all, between when the sun is partially eclipsed and when the sun is fully eclipsed. People refer to this as dynamic range, the range of brightness in a scene. So, but also during totality, there's a huge range of brightness between the inner part of the corona near the sun and the outer parts of the corona. And if you want to capture those, you got to be aware of that and take, do what you need to do. And again, that's for later. So what if you only have a cell phone? What if you only want to only use a cell phone? You can do lots of stuff. You can, again, take pictures of your where you are, the people around you, what's happening with the light, and even the the eclipse itself. Phones today, a lot of the higher end phones have terrific cameras. They have multiple lenses, some of them, and when you zoom in, you're using a longer focal length lens, so you can actually get some decent magnification on the eclipse with just using a cell phone. Now there's some apps. There's an app for everything, right? So there's some apps that will help you. One of which is called Solar Eclipse Timer, and it doesn't do any photography per se, but what it does do is help you with the timing. So the timing is so critical between when the partial eclipse starts and when the total eclipse starts and ends and so forth. And this app will gives you that information for your location. Since most phones have GPS built in, they know where you are. And Solar Eclipse Timer uses that information because, again, where you are is very critical to the timing of the eclipse. If you're 50 miles away, the eclipse will happen at a completely different time. Then there's another app called Solar Snap that does do the actual photography, and it kind of takes over your camera and you have more control over photographing. And it's designed for photographing the sun and the eclipse. So here's timer, some information about Solar Eclipse Timer. And I will say that there's a lot of other apps. These apps are have been recommended by many people as ones that are very good to use. And here's Solar Snap. Now, the thing about Solar Snap is that it's just an app which is free and will help you again take photographs of the sun and of the eclipse. It allows you to zoom in the camera with these sliders in the app, adjust the exposure, adjust the focus, and you can practice on the sun, when it's not an eclipse. But like all other instances, all other considerations when talking about the partial eclipses, you do want to use a good solar filter with your cell phone or with any other camera, or especially looking at the sun visually, whether it's partial phases or not during totality. You don't want to use the filter during totality, but during partial phases or out when the sun's completely out of eclipse. And the neat thing about this app is that you can get a version which comes with filters, and it has a little it has little Velcro tabs you can put on the filter and on the camera, and stick the filter on there, or take it off, when totality happens. So it has lots of instructions on how to use it. So that's one recommendation. So another thing is to use a tripod, especially if you're like taking time lapses or videos. You want a nice stable platform, and these little tabletop tripods are pretty inexpensive. They're available, from Amazon, various other dealers, and you can get a bracket that holds your cell phone. They're very adjustable for any size phone, and they're very versatile. So even if you're not doing the eclipse, they're useful for other things. So like I said, they're not very expensive. The other thing is you might think about an auxiliary lens. They have these little lenses you can get that snap onto your phone, or various other little adapters that allow you to put them on the phone. And again, they're not very expensive. I've seen a whole kit that it comes with a tripod and a couple of different lenses and a bracket for like $50, or between $50 and $100. So, I don't know how much better these would be than a regular cell phone that includes a telephoto lens, but it's something else to consider. And just a summary of this. I should say at the outset that if you've never photographed an eclipse before, you might consider not doing it. And that sounds counterintuitive since we're talking about eclipse photography here. But like I said, if you've never experienced an eclipse before, it's a singular event and a rare event. And lots of people are, very involved in it, and because it's just such a different event. And so what you don't want to be doing is fiddling with your camera, any camera, while the totality is going on, because it doesn't last very long. That 4 minutes will go by very, very fast. So, one recommendation is that if you're not real experienced, then you might want to just consider watching it, because it is an amazing experience just to watch. But, having said that, these are the kind of tips. Again, use a filter during the partial phases, because certainly for viewing the eclipse with your eyes or any optical device, whether it's your camera, a pair of binoculars, or a telescope. And if you are using a filter with any optical device, you want to put the filter in front of that device. Like if you're using binoculars, you want to have filters on both sides of the binoculars in front of that, not between your eyes and the binoculars, because the sunlight will be concentrated by the optics and will burn a hole in the filter and therefore burn a hole in your eyes. So you got to be a little careful with that. And you might want to use a tripod, just again for more stability. You might want to try an auxiliary lens. You want to, especially for totality, because the light is so different, it's probably best to certainly want to turn off the flash, because your flash is not going to do anything. I mean, of course, most cell phones, they won't flash unless they need the light, but they might, it may get dark enough. It will probably get dark enough, so it may want to use the flash, but you probably want to turn that off and turn off autofocus if you can. And then if you're using a Solar Snap app, it will help you with the focusing. So, what about more advanced? If you've got some equipment, if you're, more experienced with using more sophisticated equipment like a DSLR, you can get some amazing results. And you saw some examples already. Any camera really will do, whether it's a high-end, professional quality, a digital SLR camera, or a point and shoot, or a more mainstream kind of camera. It'll do, especially for the environment shots, the people around you, the landscape, the lighting, and so forth. For the more close-up stuff, the more sophisticated stuff, you do want a camera that has more control. You certainly want it to have manual control, manual focus, manual exposure control. Because again, the light is so different and variable that you want to be able to control that very carefully. In terms of lenses, again, as we've seen, a wide-angle lens is appropriate, as in any case for taking pictures of landscapes, normal lens for taking pictures of people. But you do need a longer lens for doing more detailed close-ups of the sun, whether it's during partial phases or during totality. Exposure, again, autofocus is okay for the landscape shots. You want manual control for the close-ups. Again, both for partial phases and totality. Exposures during totality are a little bit tricky, but there's a tool for that online, of course. There's a tool for everything. And there's an exposure calculator. And certainly, again, a tripod for close-ups, or what's called a tracking mount. So as I mentioned, the sun moves through the sky. As the eclipse is happening, the sun will move. If you're taking fairly close-up images, the sun will move through the frame from a fixed camera. There are devices that you can put your camera on that will compensate for that motion and track the objects in the sky. This gets a little bit more complicated. If you've done astrophotography before, if you've got a telescope, even a small telescope with a tracking mount, you can mount your camera either on the telescope or with a regular camera lens onto your tracking mount and use that to follow the sun. And that's very convenient because it's one less thing you have to worry about. The sun moves slowly enough so that you can reposition the camera periodically as the sun moves through the field. But again, that's something else you got to worry about while the eclipse is happening. You really don't want to do that during totality if you can help it. During partial phases, you actually have quite a bit of time because, again, it lasts a fairly long time. So about field of view, about, this determines how big the sun will appear on your frame in your camera. So the longer the lens, the longer the focal length of the lens, the larger the image will be, the smaller the field of view. And it's kind of an optimal, because you don't just want the sun and the moon to fill the field of view. You want space around that for the corona, which is kind of the main attraction of this. You want to get as much of the corona as you can. Now you do want some magnification so that you get a lot of detail. So I think in the 400 to 500 millimeter range is a really good range. Now this does depend on the sensor in your camera. So there are different size sensors. For the higher end DSLRs, they are full frame, which means they are a particular size. This is a historical terminology for what that size is, but then there are other cameras that have what's called a cropped sensor. So there's ones that are called APS-C, which is smaller than the full frame, and then there's 4/3, which is yet again a little bit smaller than the APS-C. You have to be aware of that. So effectively, the focal length for a cropped sensor is longer for a given nominal focal length that the lens will say. So if the lens says it's a 400 millimeter, then for a cropped sensor, it's going to be more like 400 or 450 millimeter, or 500 or 550 millimeters. So you kind of have to be aware of that. But again, somewhere in this range is really good, because you get enough space around the sun to show plenty of corona, but not so much that you're losing detail on the sun and so forth. So during totality, if you've been taking images during partial phases, you certainly want to remove your solar filter, because you won't see anything. You won't get anything. Whether you're looking through it visually or photographing, you won't get anything if you have a solar filter on during totality. And those timing apps, so even if you're taking pictures with a fancy camera, that Solar Eclipse Timer app is useful, because it will tell you when things are happening. It'll tell you when the eclipse is starting. It'll tell you when totality is starting, when to take off your filter, when to put the filter back on. So that's useful. And again, manual exposure, manual focus. It can be tricky to focus, but if you're during partial phases with the filter on it, it's pretty easy to see through the camera, the viewfinder, and adjust the focus. And you do want to periodically adjust the focus. In fact, temperature changes affect the focus in the camera. So the temperature will change during the eclipse. You will notice that as the eclipse progresses through the partial phases, it actually gets cooler, because there's less sunlight falling through the atmosphere and on the ground. So that will affect your focus somewhat. It's not a huge effect, but you do want to pay attention to that, and because you don't want it to be out of focus during for totality, if at all possible. Again, I mentioned the wide brightness range, the wide dynamic range. You want to take wide bracket sequences covering a large exposure range. And again, the exposure calculator can help with this. It has a form where you can fill in your camera information and different parts of the eclipse, and it will tell you what recommended exposures to use. But even with the recommendations, you want to bracket around those. And a lot of cameras will allow you to set a bracket sequence. And so as you hold down the shutter, it will just automatically take that number of exposures. So my camera takes up to 9 exposures with 1 stop in between them. So I can take an 8-stop bracket sequence, which is kind of nice. You want to shoot in RAW mode if at all possible. That does require some post-processing, but it does preserve all the information that your camera recorded. Whereas if you take pictures in JPEG mode, the camera actually tries to optimize that image, but in the process, it's actually throwing away some information. So it's preferable to preserve the raw mode images, and then after the fact, do your own processing to optimize the image in the way you want, rather than what the camera thinks it should be. Now, having said all that about manual exposure and so forth, the other aspects of shooting, that is when to shoot and what exposures to use, can be automated to a large extent, one way or the other. Kind of the easiest way, in a sense, is with a sequencer that's either built into the camera. A lot of cameras include what's technically called an intervalometer, a sequencer that allows you to program in a sequence of exposures, and taking it at some particular sequence of time. So you might want to set it up so, I take an exposure every 2 seconds, take 10 exposures every 2 seconds or whatever. And so you can set that up. Some cameras include that in the camera, or you can buy an accessory remote control that has this capability built into it. And that's a useful way to do it. So if you've set this sequence, then, okay, when totality starts, I set the middle of my exposure range in manual mode, and I've set a bracket sequence. And then when totality starts, I just hold down the remote control shutter, and it will fire off that many exposures in my bracket sequence. And then I'll just hit it again, and it'll take another sequence of exposures. So you're not fiddling around and changing the exposure between every exposure. And that frees you to actually look at the eclipse instead of messing around with your camera. Now, a more sophisticated way to do this, there is some software available that runs on, actually the only one that I've found is, it runs on a PC under Windows, and it allows you to program a full sequence of the entire eclipse, and it actually knows when the events during the eclipse are going to happen, programmed into it. And if you put in your GPS coordinates, it will then know those timings for your location. So you don't even have to know what time to start the sequence. It will automatically start the sequence when the eclipse starts. And you can program in all those functions of partial phases, all the time during totality, and you can program in a huge exposure range in there, and it will just fire off the exposures, and you don't have to do anything if it's set up properly. And finally, the tracking mount. If you have a tracking mount, that's another way to relinquish control of your camera so that you can watch the eclipse. Now that takes a little bit more effort to get used to setting up. And so if you're not familiar with that, that's another complication. But if you have that, then it's a great way to free up things. Now, if you don't have that, if you don't have a tracking mount, then you can reposition the camera. I just wouldn't suggest repositioning it during the totality, because again, that's another thing you're messing with. So in 4 minutes, if you're not using a super long lens, if the sun is not actually filling your frame, and you've used a lens like I mentioned, like a 400 millimeter or 500 millimeter lens, the sun will be small enough so that in that 4 minutes, it won't have moved entirely through the frame. It will move across the frame somewhat, but not entirely through the frame. So that, you don't have to worry about, you shouldn't have to worry about the sun moving through your frame during totality, unless you're using a very, very long focal length lens. So what are some of the other things to look for? So these are some of the things. There are some technical terms. This is a very long exposure, maybe 2 seconds, I believe. And the nice thing about taking these long exposures, you get the corona going way out. You see it goes all the way out to the edges of the frame. as I mentioned, you might see stars. There's a fairly bright star here, very close to the sun, which there's no way you can see that during the day normally. But in eclipse, the sky is dark enough so that the stars can. There's actually another faint little star over here. I don't think you can see that on this version. And then this other effect, which I was blown away that this was even possible in the last eclipse. Again, with these very long exposures, very deep exposures, there's sunlight bouncing on, shining on the Earth, illuminating the Earth, and bouncing back towards the moon. Now, this is the dark side of the moon, so there's no sunlight hitting the moon directly, but there's sunlight reflected from the Earth back onto the moon, and it's possible to photograph that, which I didn't even realize when I photographed that last eclipse. And then some more detailed things in eclipse. There's this effect called Bailey's beads. So when the sun, when the last little bits of the sun are just showing around the edge of the moon, you get these little dots of light. And what's happening is that the moon surface is not smooth. It's got mountains and valleys, big mountains and big valleys. And as the sun is almost covering up, as the moon is almost covering up the sunshine is coming through those valleys on the edge of the moon, and you get these little points of light. Sometimes there's a lot of them. In this case, it's not real obvious that they're little separate points of light. And it depends very critically on the timing and when you take the picture and how long the exposures are and so forth. But then the other effect is this thing called the diamond ring. So when there's a little bit more of the sun showing through, it's got this very bright area, and then the inner corona looks like a ring. So people call that the diamond ring effect. And then other things that you can see from the sun, which there's no way you can see when the sun's not in eclipse, is part of the sun's atmosphere called the chromosphere, which shines, which is the hydrogen, the light of hydrogen shining, and it's predominantly red. So you see this red glow on the edge there, on the edge of the sun. And then these wonderful prominences, these eruptions of gas off the sun. And saw a few here during the last eclipse. And now, again, the sun's going to be more active. It's nearing the maximum time of its activity in its 11-year cycle. So there's a great expectation that we'll see more prominences and sunspots. And then, the corona. So with short exposures, you see the inner corona, lots of structure here. These nice filaments coming off. And then with longer exposures, you get the outer corona. So just some things to look for and some terminology. So in terms of exposures, these are, again, because of the dynamic range, there's a huge range of exposures here. Again, this is the diamond ring. This was a 2,000th of a second. And I was using a regular telephoto zoom lens of 500 millimeters. And these are the exposures I was using. With consistent f-stop and ISO film sensitivity, you can see the difference. Now these are still there's not entirely total. So the diamond ring and Bailey's beads, there's still some sunlight coming through, so the exposures need to be a little shorter, so you don't overexpose too bad. But during totality, then you take these longer exposures to get various parts of the details. So the inner corona, more of the corona, but you still see the prominences and so forth here with a longer exposure. With longer exposure, yet you're seeing more of the corona. And then with the longest exposures, you're seeing the very outer parts of and more than filling the frame. And then you see the Earth shine. And you can even see some details there on the moon with the Earth shine, which is, to me, fairly remarkable. But these are kind of starting points for the exposures. Again, that exposure calculator is a good place to start with finding exposures. This is the equipment I used for the last Eclipse. Just some details about this. Again, a regular DSLR. In that case, it was a Nikon D800 full frame DSLR with a 200 to 500 millimeter lens. I was actually shooting at 500 millimeters. This is a solar filter. You can buy this filter material. This is the company is called Botter. There are other people that make this stuff, but this is available either as pre-made filters that fit on various cameras and telescopes, or you can buy just the material itself and make your own filter holder, which is what I did in this case to fit this particular lens. And then this is the little sky tracker that I used. It's called a Ioptron Sky Guider Pro. It's in the $400 to $500 range. There are various brands of this, and then or you can use a telescope mount, which is a little bit more sophisticated, has much more capability. But this one is fairly simple. It does take some effort to set it up properly. So you need to practice with this. So there's a lot of details with this, but once you get it working, it's a big help because again, it will track the sun and just a stable tripod. And then this is software that I used called Solar Eclipse Maestro. It works on a Mac, which is what I have. But unfortunately, it hasn't been updated for the current Mac operating system. So that's not really an option this time. But as I mentioned, for the PC world, there is Solar Eclipse Orchestrator, which works. They're essentially equivalent software. And then this is what it looked like out in the field. I actually had two cameras running. This one with a wide angle lens taken in a broader scene. And then this is a close-up one. And I had this this reflective material, part of a solar blanket, like a space blanket, they call them, that helps cool it. I mean, this is full sunlight, at least during the partial phases. So the mostly black cameras will absorb a lot of heat, and you want to avoid that. So the solar blanket helps a little bit with that. And then I'll just touch very briefly on post-processing. A lot you can say about that, but in general, well, I use Lightroom and some Photoshop. Any raw processing software will obviously work. Most camera makers provide raw processing software with their camera free. There's other third-party software. Lightroom does the job very well. And basically what you're doing with these is managing this, again, this huge dynamic range, and trying to extract as much detail as you can from the brightest parts of the image and the faintest parts of the image. So by adjusting the various sliders, clarity, shadows, highlights, whatever, you can pull a lot of detail out. With the latest sensors in cameras, they're really very, very good, and the dynamic range of the sensors is phenomenal, and you can actually pull a lot of detail out. And managing noise is another issue. Not so much an issue with these brighter subjects, but if you're doing the longer exposures, you might notice some noise, and that's manageable through the processing software also. If you want to get more sophisticated, you can do a composite with different exposures, high dynamic range processing, and then again, time lapses. There's Lightroom and other software will that's really about HDR composites. Lightroom will do HDR, Photoshop will do HDR, other third-party software will. There's separate software you can buy to do those. Time-lapse, again, there's software that will allow you to put together a time-lapse sequence from still frames. I'm not going to talk about video. I don't do much video, but like I mentioned before, a lot of people will. do video. And of course, there's software to deal with that also. So just one post-processing thing, HDR. Here's a sequence of exposures. Now this covers a 10-stop range. That's a fairly large range of brightness. So as you can see, again, we're getting, detail in the very inner part of the corona, and we're getting with the shortest exposures, longest exposures, we're getting detail in the outer parts of the corona. And to capture that all or to render that in one frame, you do need to composite those images somehow. Now, in this case, I didn't use the automatic HDR processing in Lightroom. I took the frames into Photoshop and used masks to blend those frames together. So it took the best parts of the longest exposures. For example, the Earth's shine on the moon. You see a lot of detail now in the moon, but then also you see all the detail way down into the inner part of the corona. It's maybe not as high contrast as in the single frames, but it's very difficult to maintain that contrast throughout all those frames. Now, there's a lot more sophisticated processing that can be done to enhance that. Frankly, some of them look pretty unnatural, but this is already pretty unnatural because you can't see this with your eyes, but it's neat that you can capture it with photography. And that's what I like about doing photography, because you can capture things in the camera that you cannot see with your eyes. And just a brief summary, again, really avoid fiddling with equipment if you possibly can, especially during totality, because there's so little time. And you want to experience the eclipse. You want to experience it with the people around you. If there's people around you, it's a fun time. Use a solar filter. There's a lot of things about the filters. There's, again, links in the resources, or you can just search online for information about solar filters. You do want to make sure you use a quality solar filter. There are some knockoffs and things that you want to avoid, because it's dangerous, especially if you're looking through with your eyes. You don't want to damage your eyes. I will mention there's people ask questions about, is it okay to use a neutral density filter on a camera, which for regular photography? These are filters which cut down the amount of light. In some cases, dramatically. You can buy neutral density filters of different darkness, and will cut out less or more light. Now, the highest density neutral density filters still really are not dense enough to cut down enough light. The approved solar filters are cut down the light by a very small fraction, and it's like 16 stops. And that's a lot of light change. You can't really get a neutral density filter that's that dense. And the other thing is that neutral density filters generally work by absorbing the light and transmitting only a tiny fraction of the light. But while they're absorbing it, they're also absorbing heat, and they will heat up and may actually crack and break because they're made out of glass. So you got to be very careful with that. I would not recommend using a neutral density filter, but some people have successfully. Again, for the lens, use a moderate telephoto lens. You want to have enough field of view to get the corona. Try to use a tracking mount if you can, and bracket the exposure because of the wide dynamic range. And again, automate as much as possible. And if you can practice, you can practice for partial phases by anytime it's clear during the day, just go out and shoot pictures of the sun with your solar filter. That gives you lots of practice for that. It's more difficult to practice totality, but the timing you can practice, especially, and the sequences. So if you set up a exposure sequence, bracketing sequence in your camera, you can experiment with that. You can see if it's working as you expect and how long it takes and so forth, and make sure your remote's working and all those things. If you're using the software, you need to prepare. You need to to generate the script that the software is going to use to take those exposures. So there's lots of things to prepare and lots of ways to practice. And here's a set of resources. I won't, you don't need to write down these links. As I mentioned, there'll be a resource which has all these links in it. And then there's also some sources. Here's some sources for people that sell the filter, the approved solar filters, optics, those accessory lenses for your cell phone. You can get those from Amazon. Places like B&H Photo, which very extensive inventory of photo equipment, and other accessories for this kind of stuff. But they're specialized. The Egina, High Point, and Woodland Hills are specialized astronomy equipment vendors. So those are good places to go. I don't have any association with any of these places except the embarrassing amount of money that I've spent with most of them. But I will leave it here, and that's really all I have to say. And again, thanks for coming and thanks for listening. And I'm happy to answer questions.
Thank you very much for an absolutely terrific talk and for sharing your expertise with everyone here today. The first question we'd like to ask is from Christine Garrison. She asks, can you talk about the shadow bands? They were weird and amazing right before, during, and after Totality last time. I don't think I've ever heard a good explanation for them.
That's a really good question and something I just glossed over because I've actually never seen them, but I've heard about this effect where as the shadow of the sun is approaching on the ground, and you have a good flat surface with maybe a bed sheet laid out on the ground, kind of as a screen, you may notice the light rippling a little bit, these bands of shadows moving across very rapidly. And those are called shadow bands. And honestly, I don't know what the explanation is. Probably an optical effect with the atmosphere and this relatively sharp shadow going through the atmosphere. But I've seen pictures where people, or videos where even against the side of a wall or a car or something, people will see this kind of rippling light. So that's something to look for. And I would think almost impossible to photograph, but it's always worth a try. And probably video works better because it is moving.
Oh, thanks for that terrific explanation. The next question we have still open is from Madeline Shepley, who asks, is there any way that you can do it yourself or DIY a tripod for a phone if you're unable to get a tripod for some reason?
Yeah, I suppose there is.
Can you MacGyver it?
Sorry?
Can you MacGyver it?
Duct tape? I don't know. There's always some way. But those little brackets and stuff are really pretty inexpensive. If you've already got a tripod, a photo tripod, just getting a little bracket they usually have a tripod socket on it that will fit on a tripod. But in terms of something else, I mean, I guess you could rig something up with little sticks of wood or something, and like I said, duct tape it or something on there. If other people have suggestions, I'm open to that.
About the only thing I can think of is for aurora photography, we were without a tripod, just a phone, and we just braced it against a tree, which would cut down on the vibrations. It was still a little wiggly, but for these short exposures, maybe that might work.
Yeah. Well, what's amazing, again, with the latest cell phones, I've taken pictures at night, where I thought I would never get a sharp picture, but they have like motion compensation built in in the phone, and it will take a sharp picture several seconds long. And it's just remarkable. But yeah, just bracing the camera against something is always useful.
Great, thank you so much. Our next question is from Christine. She says, looking at the stellarium map, the sun will be slightly higher in the sky on the 8th at 3:10 than it will be tomorrow. If you wanted to, and so I guess she's asking if it would be a good way to help scout for a location that if it's visible tomorrow, is it safe to say it will be visible on the 8th?
Yes, it's not going to changed that much in the less than 2 weeks we have. So yeah, that's a good tag.
Fantastic.
And there are apps that will show you the exact view. Like I have an app called Sky Safari, and it has a mode that will use the phones. It's an app that you can install on your phone, and it's got an augmented reality mode where it will show you the scene using your phone's camera. Superimposed on that is the view of the sky. So you can see exactly where, and you can change the date. So you could go to April 8th at that time, and it will show you where the sun is, where you are. So that's kind of cool.
Oh, that's a great tip. Thank you. I see one more question here in the audience. This is from David. He asks, were the images showing Bailey's beads acquired with or without a solar filter?
I believe they were without, because those exposures were not that different from the exposures for Totality. So I took, again, those, the apps that give you the timing, like even that Solar Eclipse Orchestrator that also controls your camera, will also tell you when to take the filter off. So right before like Bailey's beads is going to happen, they tell you take the filter off.
Oh, fantastic. That's really helpful. Thank you everyone to the audience for really engaging questions. Actually, I had one last question to ask too. In the one picture where you had the solar prominences showing, was that taken through a white light filter? Because ordinarily we wouldn't expect to be able to do that in a white light filter.
Yeah, I guess there's enough emission. Well, the problem is that that most of the emission from hydrogen like that's coming off the sun is actually a little bit into the infrared. It's not really visible light. And most cameras actually block infrared light for various reasons, technical reasons. And so they actually block the primary part of that hydrogen emission. However, there's enough spillover in the light that it's the sensors are sensitive to enough of that you can actually see the prominences and the chromosphere.
It was really fascinating to see it in that shot. Thanks for that.
Yeah, I was actually kind of surprised that it worked out well at Eclipse.
Well, thank you. And I don't see any additional open questions from the audience. So I want to thank again the audience for attending and pass the presentation back over to Vanessa Chloe, who will close us out for the day.
Great. Thank you again for joining us and participating in this evening's live stream. I would like to personally thank Mr. Levay and Professor Macklin for their time and expertise. We are grateful to you all. Finally, I should acknowledge that events like this would not be possible without the support of donors who understand the value of a liberal arts education. If you would like to support programs like tonight's presentation or other opportunities that connect alumni and friends with the College of Arts and Sciences, please consider making a contribution to the IU Bloomington College Alumni Engagement Fund at the Indiana University Foundation. We hope to see you again next time, but until then, please take care.